Hey guys, Miss Bendon here. Last night, Mr. Keener went over some methods for solving quadratic equations by factoring them with you. And when we've got one that looks like this, that's pretty straightforward. We can see, alright, we've got a 2, a negative 2, and a negative 12. So right away, we want to pull out that GCF of 2, and that's going to leave us with x squared minus x minus 6 equals 0. And then I want to focus on this piece that's inside the parentheses. And I can factor that even further because I've got that setup of 1x squared, and then I've got a minus 1 as my b and a minus 6 as my c. So I'm going to look for two numbers that add to negative 1 and multiply to negative 6. And if I think about that for a moment, I can go, alright, that's a 2 plus negative 3 equals negative 1, and 2 times negative 3 equals negative 6. Great, so I can rewrite this as 2 times x plus 2 times x minus 3 equals 0, and I've got it fully factored. So then I've got to go back to that zero product rule that Mr. Keener talked about last night, where if any one of these factors is equal to 0, this whole thing is going to multiply out to 0 and the equation will be true. So I can start by just looking at one of these factors, x plus 2, and say, alright, well, if x equals negative 2, then negative 2 plus 2 equals 0, and that makes the whole equation true. Or I can look over at the other factor here, x minus 3, and do the same thing. Say if x is 3, then 3 minus 3 is 0, and the whole equation is true. So I've got my two solutions just by factoring, and that was pretty fast. But if we've got an equation that looks like this, 3x squared minus 12x plus 4, if I look at that, there is not a GCF between 3 and negative 12 and 4. So there's nothing I can pull out of there, and if I start trying to factor that one, it gets messy pretty quickly. So we're going to fall back on a different method that we can always depend on to solve quadratic equations, which is the quadratic formula. X equals negative b plus or minus radical b squared minus 4ac all over 2a. The good news is you don't have to memorize that. It's on the reference sheet for the Regent exam, so it'll be given to you. You just have to know how to use it. So what we're going to do is pull out those a, b, and c values that we've been pulling out of our quadratic formulas in standard form all along, and this one's already in standard form for us, so we can just say a is 3, b is negative 12, and c is 4. So I'm going to plug that into the quadratic equation. X equals negative b, b is negative 12, so we've got negative 12 is positive 12, plus or minus negative 12 squared minus 4 times 3 times 4 all over 2 times 3. And then we've got this big chunk of arithmetic that unfortunately we cannot just plug into our calculator the way it is because we have this really complex radical here and our calculators don't know how to simplify radicals for us. So what you're going to do is plug just the piece under the radical into your calculator, and if you plug in negative 12 squared minus 4 times 3 times 4, just like that, you should get out 96. So we've got 12 plus or minus radical 96 over 2 times 3 is 6. And that's an answer, but it is not a fully simplified answer yet because we can simplify that radical. So I'm going to take that radical 96 over here and we're going to do a little bit of side work with it where we're going to break radical 96 down into its prime factors. So 96, well, I'm looking for two numbers that multiply to make 96. Right away I see that it's an even number, so an easy one to pull out is 2, and that's 2 times 48. 2 is prime, so this one is done here. I'm going to circle it to indicate that that branch of my factor tree is finished, and then I'm going to keep going with 48. I can break 48 down into 6 times 8. 6 times 8 is 48. 6 breaks down into 2 times 3. Oops. So we've got 2 times 3. I don't know if you guys can hear all the crazy noises happening in the background. That would be my cats destroying my apartment as I make this video. 8 breaks down into 2 times 4. And then 4 breaks down into 2 times 2. Alright, so now all of these are primes. Every branch ends in a prime number. So I've got a fully factored 96. So here's what we're going to do with this. Everything, we're going to create another radical over here. And everything that has a match is going to move outside of the radical. So I'm just going to say that I've got a 2 and a 2. That's a match. So that puts a 2 outside the radical. And then I can make another match, 2 times 2. That puts another 2 outside of my radical. And then I've got a 3 and a 2 left that don't have matches. So the 3 and the 2 that don't have matches are going to go inside my radical. And I'm just going to multiply those. I've got a 2 times 2 outside the radical, so that gives me a 4. And I've got a 3 times 2 inside the radical, and that's going to give me a 6. So the square root of 96 simplifies to 4 times the square root of 6. So that's just the radical 96 that we've simplified. The rest of it is still in here. So we've got x equals 12 plus or minus 4 radical 6. Lots of formatting to make this readable. All over 6. And then we can simplify that a little bit further because there is a GCF between the 3 terms that we have in this solution. We have a 12, a 6, and a 4. So 12, 6, and 4 all have a GCF of 2. So I'm just going to divide a 2 out of this equation. So that's going to leave me with an x equals, or really I shouldn't call it a GCF. I'm not factoring. I'm simplifying a fraction is what I'm doing. But we do have to look for a GCF between all 3 terms in order to simplify this fraction. So I can simplify by dividing all of these terms by 2, and I've got 6 plus or minus, which isn't an easy thing to type for whatever reason. 6 plus or minus 2 radical 6 and you'll notice that that 6 inside the radical is not being divided by 2. We can't do that. Order of operations, that has to be under the radical before we can do anything else to it. All over 6 divided by 2 is 3. And that is, well, actually, we can simplify that a little bit further. So then that's going to equal 6 over 3, and 6 divided by 3 is just 2, plus or minus 2 radical 6. What am I doing? I need a line. 2 radical 6 over 3. So simplifying the quadratic formula was kind of lengthy. We had to know how to simplify that radical, but we really couldn't have factored any other way and gotten to this answer of x equals 2 plus or minus 2 radical 6 over 3. That's not something we could have gotten to by factoring. That's not a rational solution. So when every other method fails, you're going to move to the quadratic formula, and that is going to come up on the Regent exam quite a lot. We've got an example here of one that would be on the, this is straight from the Regent, and we've got x squared plus 4x minus 16 equals 0, and right away when we look at these multiple choice options, we can see that we probably need to solve this with the quadratic formula because those answers are in the form that our quadratic formula answer took, a number plus or minus something with a simplified radical. So we would plug that straight into the quadratic equation, and then we would just start to simplify. So see if you can simplify that one on your own, and we will talk about this and get a little bit more practice in class tomorrow.